Here's a more generalized way of thinking about put-call parity. And it uses the notion discussed in an earlier chapter of a prepaid forward. Recall that when we talk about the forward price of a stock at time t, that's the price we will pay at time t for that stock. It's a forward price because we determine that price at time 0. In this notation, f sub little t, big T, that would be without the p. That would be the forward price at time little t for a stock at time capital T. The prepaid price is the cost of that if you decided to pay it at time little t. In other words, let's say that we enter a forward and we want to pay the appropriate price at time capital T. Well, that's in the notation of the author, FTT. FT, capital T, is the price we determine at time little t for the stock delivery at time capital T. When we put a P up, that's the prepaid price. Instead of paying for that delivery at time capital T, if we wanted to pay for it at time little t, that would be called the prepaid forward price. So we actually make that payment at time little t, and then at time capital T, we just get delivery of the stock. And in this general relationship, what we're saying is that if we have a call on S and Q, it may be a constant like a T-bill, or it could be another security, which we'll call an exchange option later. A call on S where we provide Q to buy it, and then we short a put on S where we sell S for Q, that's going to be equal to the prepaid value of S minus the prepaid forward value of Q. And in fact, we'll go through this table. This generalizes put-call parity, but let's go through this example. So first of all, if we buy this call, you see on the left-hand side, this will be the cost. We're going to buy the call, sell the put. We have a forward on S, and we're selling that, and we're buying the forward on Q. So what happens at expiration? Well, it depends on the relationship between S and Q. So if S is less than Q, what's going to happen? The put will be exercised, right? Because the put is the option to sell S for Q. If S is smaller, so there'll be a cost of S minus Q. We then have a prepaid forward on S. It'll then have value ST. Q, you add them up, you get 0. Same argument, if S is bigger than the value of Q at time T, the call will be exercised. The two prepaid forwards, we now accept delivery of the instruments that we had forwards on, and again they add up to 0. So what we have is that if we buy a call and we short a put, we have exactly the same payoffs as if we went long a prepaid forward on S and we shorted a prepaid forward on Q. So these are all contracts that are implemented at time 0. We can see on the right the expiration value 0, therefore the value on the left, which is the value at time 0, or time little t, that also has to be 0. This is the argument we saw earlier, that if two portfolios have the same value at time t, they must have the same value earlier. And we looked at time 0, but here it's time little t. This is a useful way to think about things because automatically it provides us with put-call parity for other contracts than stock. So we've already seen this one, stock with no dividends. And you can see, going back for a moment, that in a table we were just looking at, this expression for put-call parity has been rewritten in terms of the price of S.